Hello everybody. In today's video, we're going to cover inverse functions. So I'll go through two basic examples of what inverse functions are and how to solve for them. So on the bottom of the screen here, I'm going to explain really quickly what an inverse function is. So usually when you have an inverse function, it has to do with graphs. So we'll take the graph of, y equals x to start off with. So this y equals x graph will look something like this. Now, we'll call this just f of x. And if we take another graph that looks just like this, we'll call this f of -1 of x. F of -1 of x is known as the inverse. So mathematically, if you were to combine these two functions, recalling the video that we just did about the function properties, if you make a composite function, so f of -1 of x is going to get you just x. So what does that mean mathematically? Well, I'll explain this graphically just a little more, but let's go quickly over what this means mathematically. So let's solve for the inverse of x squared. So the first thing we're going to do is replace this f of -1 of x with y. Now we'll call this y equals x squared, f of x with y. And now we're going to swap our x and y values. So we get x is equal to y squared. After we've swapped all x and y values, we're going to solve for our x. How do we do this? Well, we square root the y, and we get y is going to be equal to square root of x. This is the inverse of x squared. So f of -1 of x is equal to square root of x. Now what does this mean? Once again, if you take the composite of these functions, what do you get? Well, let's see. So if you plug in square root of x into our x over here, you're going to get square root of x squared. And what does that get you? X. So regardless of whatever value you have for that inverse function, you're going to end up with that original x value. This is what it means for a function to have an inverse. Now usually on a graph, they're often rotated around some specific axes. So I'll try to draw it here to the best of my ability. Actually, let's scroll down a little bit for this so we have some more space. So if I were to graph x squared, something like this. Sorry for the bad drawing, but if I were to graph x squared on this graph, it'll look like this, right? You can, if you want to, you can look it up online or graph it out yourself. But if you now take the graph of the inverse, which is just square root of x, square root of x looks something like that. Now what does this mean? Well, if you take the right hand side of this graph and if you rotate it, you end up getting this shape. If you rotate this part of the graph, you're going to end up getting this shape. And therefore we can actually graphically confirm that a function has an inverse. But once again, going back to our mathematical confirmations, let's go through the second example. So how do we solve for the inverse of this if it has one? So keep in mind that functions may not have inverses. Well, once again, replace that f of x with y. So we get y is equal to 2x squared plus y, 2x squared plus 5, sorry. Now swap our x and our y, and we get x is equal to 2y squared plus 5. Now subtract 5 for both sides because we're solving for x now. We're trying to isolate our y. So we get x minus 5 is equal to 2y squared. Divide both sides by 2. You get x minus 5 over 2 is equal to y squared. And finally, the final step, you square root both sides. And your inverse becomes x minus 5 over 2 is equal to f of -1 of x. So you can check it up, or you can do a check step and plug in this value as your x. What happens? Well, right off the bat, the square over here gets rid of this square root. So it gets rid of that square root. The 2 over here, multiplying by the x squared, gets you rid of that dividing 2. And adding 5 right here gets rid of that subtracting 5 over here. And once again, we end up with just x. So that is what an inverse function is. Now in the next video, we're going to find out how to graph functions, and we're going to figure out how to solve functions based off their graphs.